the Arthur Chung International Conference Center. It's Mining Week 2015 under the theme Science and Engineering Solutions for Safety, Security and Success in Mining.
Our next presenter will be presenting on the Guyana Geological Timescale, and it's by Dr. SergeNadeau, who works for Guyana Geology and Mines Commission. Dr. Nadeau provided me with a bio that would probably take me the rest of the morning to say what he's done. But suffice to say, he has a lot of international exposure in mining and geology, and we're very happy to have him with us this morning to present on the important topic of the Guyana Geological Timescale. Dr. Nadeau.
Good morning, everybody. I will talk about something. I made a compilation of age dating results of Guyana. I was involved in some of the work, and I made it visually more friendly for people. So I made it could be distributed freely for schools, all of that. And but before that, I will review the previous work that were done in Guyana. So quickly, I will cover a little story about the geology of Guyana, the surveys, various time scales that were produced, age dating results, and that poster that I made was supposed to be published as a handout and distributed here, but due to budget constraint, it's not ready. So, and what next need to be done? So geological work in Guyana started in the 1860s by Barrington, Brown, and Sawkins. And the report published in 1875 is very interesting to read, enjoy reading, because he described all the work done day by day. So the name of the geological survey changed through time, pre-independence and post-independence. And GGMC as an entity exists since 1985, plus or minus 1 year also, with several divisions. Large part of the country have been mapped at 50,000 up to 200,000, depending the access and budget. So all the data was compiled into a geological map atlas that are at the library at GGMC. And some of those maps are starting to be updated with more recent works by the Geological Survey plus mining companies. And they are done by, they are updated by Andy Camp and Linda Easterman. So it covers between 1960s up to today. Several work were done through time, and for me the most important work that came out was the book, The Geology of the Guyana Shield, published by Gibbs and Barron, two geologists at GGMC, and is still one of the Bible of North and South America geology. And okay, since 1999, GGMC changed completely their way of doing work, and mainly to help miners to evaluate the potential of the geology of Guyana. We have started what we call regional geochemical surveys. So 32 projects were done of regional geochemical surveys, and several of them, the reports have been published. Some are still waiting, pending, and they could be bought at GGMC. For this story, I came the first time in 2004 to 2006 as a VSO volunteer, went back in Canada for 3 years, froze in the north for 3 years, and decided to come back in 2009. And now I will show you, okay, the various, I call it geological time scale. It's easier to see than lithostratigraphy table of this and that. So the first one I could find was by Barrington Brown in 1875. At that time, there were no age results that existed. But he was able to look at the stratigraphy order of the various formations and make an order of it. And, but I will say those rocks here, those formations now will be here, and those one will move there based on age results. But at that time, that was already pretty good to be able to do that. That one is a bad shape copy, but that's the one came from the library, scanned it 2 weeks ago. And there also, at the time of McConnell, there were no age results. One rock was submitted for dating only, but the result was not out when this table was made. And as you see, it's called a provisional stratigraphy. So it's mainly based on the order of the rocks that are found, observed in the field. And the subdivision of Guyana based on those geological formation and order of occurrence. In the 1960s, age dating started in Guyana. I will show the results later on. And Byron did a subdivision of Guyana in 3 zones. And there, because they have different sequence of rocks, for the northern Guyana, which is the northwest, the people call it here, and in the central part is the Tekutu Graben. And southern Guyana is from the Kanuku Mountain down to the border to Brazil. At that time, a few potassium argon age came in only. And one dilemma that was existing already at that time was the age of the Pacarama Mountains that are formed of the Roraima Formation sediments. And on the Venezuelan side, it was thought that based on some observation of possible fossils that the rocks were about younger than 300 million years or 400 million years. But on the Guyana side, potassium argon were suggesting it's older than 70 million years, or even more than that. And in fact, it's much more. So Cannon and McDonald started to make a more detailed geological timescale, as I said, based on the stratigraphy of the rocks, using a lot of potassium argon data that came in. And Béranger in 77, we did a lot of potassium argon with snelling, potassium argon dating, and a little of rubidium strontium. For southern Guyana, they were able to subdivide much more in detail the sequence of the rocks based on the potassium argon age. Although there is a lot of limitation on the results of potassium argon in terms of precise age values. But since, let's say, the compilation done by Gibbs and Barron in 1993 for the Guyana Shield, the time scale have always come back for all the publication that exists in Guyana. So I'll show you just a few variations on the same theme. So the same time interval, geological formations, lithostratigraphic units are always about the same. So when I came at GGMC in 2004, a simplified version of Gibbs and Barron is the one we had on the network to look at what is the history, geological history of Guyana. Pretty simple, and just a few age range. The last one I found that was published 2 years ago is by Lowe for Northern Guyana. He was reviewing the mineralization throughout the country, mainly the northwest part, and still using the same age range as since Gibbs and Barron. He just did a little more variation in terms of the tectonic, but the lithology did not change, lithostratigraphy, all of that. So I'll show quickly those results through time. So the first age dating that I could find was by Darnley in 1960. I was on monazite crystals. They were loose and stream sediments from southern Guyana. And during the 60s, 70s, a large amount of age dating results came in by potassium argon. The work was not done in Guyana, but in some laboratories in England and in the States. The names are given here. There is probably more than that, but that's what I've found up to now. Most of them are rubidium strontium. In the 1980s, people shifted to zircon dating by uranium lead. But at the beginning, they were analyzing multiple zircon grains by thermal ionization mass spectrometry TIMS. The most recent work that was done by uranium lead on zircon is in 2014 by Alexander. I will show later on where it was done. An interesting result also was dating gold by the rhenium-osmium method. That was one study, but never published as a paper, just as an abstract. But it gave an idea of the age of the gold mineralization itself. And you could look at it also by the mineral associated with gold. Normally, that's the way which is done. So I got involved in that in 2011, but the age results came in 2013-14. I was using laser SCP-MS with a friend from China. And then last year I went in Brazil and brought some rocks for dating by shrimp, we call it. So just to show how the distribution of the age changed through time and the number of results. So the first is Snelling and McConnell. So the map is very pale. So put our geological map and overlay in blue the potassium argon values. Snelling and Béranger did much more potassium argon dating. Yep. So you see it by all the blue values. I don't have time to explain those methods and the limitation, but potassium argon is very sensitive to diffusion of argon. So you have argon loss, so the age is younger than it should be. And sometimes the reverse happen is you could have potassium affected by metamorphic process and you lose it, so the argon is higher, you have an excess argon, so the age look older than it should be. So it's working well on fresh rocks, but much less so when you go in old rocks. A few rubidium strontium results came out also by Snelling and Béranger, mainly down south and along the border, but the rest was not covered. Okay, the first uranium lead zircon data that came out was by Darnley in the south. So those were loose monazite crystal only, and they were assuming that it's reflecting the surrounding rocks. Gibbs, during his PhD and subsequently in a paper, he published a few zircon age. Those are still a mixture of several zircon grains. So that gave an idea of the northwest, the age of the rocks in the northwest, the greenstone belt, and those up to recently to the work I've done were the oldest for rocks in Guyana. Okay, a little more recently, two studies were in focus on some deposits. One by Norcross at Omai, dating the host rocks, the greenstone belt. The age, the gold mineralization was dated, not the gold, but the mineral associated with it at 2 billion years. And at the bottom of the pit, there is a dike that stopped the mining. And the dike was dated. They never went through for the gold underneath because it's too thick, but that's much younger and correspond to some of the rocks in the Roraima formation. The last study that was done by Alexander was the uranium mineralization in the Kurupung batholith. And what is interesting is when you look at the age of the uranium mineralization, it's the same age as the gold mineralization. So depending on your surrounding rocks, host rock, on one side in the granite you got uranium mineralization, and the south in the greenstone belt you got gold mineralization. So it's the same tectonic process that produced those two deposits, although completely different. Okay, so my involvement was in 2011 with the Brazilian geologists from the CPRM. So that's the field crew, so people from Guyana and also the team from Brazil. So we're working on both sides of the border and we wanted to correlate the geology for the South America map of the geological map of South America to correlate and agree with the age value of those rocks. So for us in Guyana, since except for the two studies on Omai and for Kurupung, nothing has happened since the 1980s. And no work were done on uranium-lead dating by zircon on rocks from the southern part of Guyana, like the Kanuku complex, which are the Kanuku Mountain, Iwakarama Formation that people here call the South Pakarama Mountain, and also all the granite to the south. So 18 rocks were collected from those three different formation of groups, and I got lucky. The Chinese was overzealous, and he did 447 age determination on zircon. So it's a slew of results, I will see. So I'm still working on it sometime. So the method that was used in China by David Chen, who came as a volunteer in Guyana for a year, was by laser ICP-MS. His little name is there. And so this allowed to do spot analysis within one zircon grain. And it's very important, as you will see in a minute. And last year I went in Brazil to have access to the shrimp, which is a huge monster, mass spectrometer. And in collaboration with Professor Cordani, I could get a few more rocks dated. So the zircons are extracted from the rocks. Just jump one. And then what happened is the zircon are polished, and by cathodoluminescence light, we look at the internal structure of the zircon, because sometimes they contain core and a rim that could have different age. So that's very important for the understanding of the evolution of the rocks. So some zircon are homogeneous and some have those core. And we got all kind of surprise with that, I will tell you. So in general, well, this is a plot of the 447 zircon. It's a histogram. And the first results confirm what we knew already, that most of the rocks are Proterozoic in age. And they range between 1.95 billion years to 2.1. But the surprise that came out was we got zircons that were between 2.5 and 3.8 billion years. Up to 2.8 billion years are present in the Kanuku that reflect all they are metasediments that were high-grade metamorphosed. And so they were accumulating from something else in the surrounding at the time. And even more exciting than that was one guy gave an age of Hadean period. Hadean is more than 4 billion years, and the zircon age is 4.22 billion years. So that was quite a surprise. That's in the core of one of the zircon we got. So just to show you quickly where it was. So it's in the central part of Guyana, which is what we call the Iwakarama Formation. And one of the granite, the Toka granite, contain those zircon. So just to show you, Toka community is here. The Toka granite is that mountain plus the hills around. And where we went and we collected the samples. Obviously at that time we had no idea that there were any Archean and Hadean age. We got really lucky. So we took some picture for fun because it was a nice view of the area, all of that. And so the granite is reflecting the magmatic chamber of a volcano. So the magma cools slowly and you form those crystals in the granite. So they are fine to medium grain. So we call it a subvolcanic granite, just underneath the grass of the volcano. So in the rocks, there is various minerals reflecting the chemistry of the granite. And within the biotite crystal, there is those little crystals of zircon that are between 50 and 200 microns that were extracted. And so coming back to the picture I showed before, in fact, That crystal is the Hadean zircon with its core part and the rim. And the laser ICP-MS is drilling through the zircon. So that's the only way we could find it, because the core was not really exposed on surface. With the shrimp, they will have missed the age of the Hadean age on that zircon. Even better than that, David did 3 analyses in it. The first one, he got 4.21 billion years. And so later on, during during the analysis, he came back, did a second analysis, and got 4.22 billion years. And in fact, what was even amazing was the age was concordant for the 2 geochronometer. When uranium-238 decomposed in 206 lead, and the 235 decomposed in 207, if the two give the same age, they fall on the Concordia curve, which means that's the age of formation of the zircon, is crystallization from the magma. So also quite important is the host rock is much younger by 2 billion years. It's 1.9 billion years. So those volcanoes were going through across, and most of it got melted. Only some of the zircon with the Hadean age and several Archean one reflect what I call a lost Hadean crust that is underneath the Iwokrama Formation. So I tried to figure out what is the extent, the minimum extent of that Hadean crust, and using the zircon age at Toka plus some that are old enough to have been probably Hadean and resetted. This area looked like where there was an Hadean crust that later on more formation accumulated around it during Archean time and Proterozoic time. So this was in contrast with the Brazilian, because those rocks extend in Brazil and they don't have any evidence of an old crust present. So it was something unique and good for Guyana, at least, to be different. So just to show where we did the dating of the Iwokrama, Kanuku, and the Southern Guyana granite. And in 2014, I took a boat ride to Bartica to get a sample from the Biki quarry. After that, with a student, I went to pick up a rock at Macarapan when she was doing her BSc thesis. I got it dated in Brazil, and in the Barron rock collection still left at GGMC, I found some rocks from the Muri complex, so I could get a date age on it. So one of the handouts you are supposed to have printed today was a geological map, and on the other side a map of all the age measured throughout Guyana through time also, from 1960s up to 2014. Sadly, it's not printed. And coming back to the poster, which is what I call the Guyana Geological Time Scale. So this was printed as a poster, made a handout to be given to the people also. It's not there too. But I will just explain quickly how it's made. So there is several components in it. So on the left-hand side in color, you see there is which is the Earth Geological Time Scale that is known and published internationally by various organizations. So on it, I put the geological time subdivisions, the number of years in million. I put a few fossils that are famous through the age of the Earth. So you have the dinosaur, and you have also the ammonites, where they are through time. And also the oldest one, which is in Australia, stromatolites. They are cyanobacteriology that still exist today in Australia and Florida on the beach. Okay, I put also on that poster and the supposedly handout the age of the Earth, the Moon system, and also I put the oldest zircon that is dated in Australia at 4.4 billion years. The oldest rock that is known on Earth is in Canada at 4 billion years. The oldest zircon measured in South America until the Toca zircon was 3.5 in Brazil. And on that poster, on the other side in red, I put various age of rocks formation in Guyana. So you have, and I put also picture of some of those rock formations. And at the bottom, I put the two methods that were recently used for age dating, plus the infamous zircon with the Hadean age. So this is what I call the Guyana geological timescale. I hope people will have access to it. So people will say, what's the application of this age dating? Well, if you look at the geological map of Guyana, how it evolved through time in terms of rock chemistry and age, this is my last version of the geological map color that is based on previous compilation that are available at GGMC. And in addition to help to constrain those geological formation, we could look where the mining activities has occurred through time in Guyana. So before 2010, and by mainly observation by geologists, and since 2010 from the mine officer database I could access, plus the geologists, you could look where the mining activities is concentrated in terms of geological formation and age of those deposits. Just to stretch your mind a little more, what is very important is that Hadean-Archean cross, that I call the last Hadean cross, under the Iwak-Rama formation, has strong implication for the search of kimberlites and the possible source of diamonds in Guyana, which before we had not an Archean cross existing in Guyana, so diamonds were assumed coming from somewhere else. But now, based on the occurrence of that cross, that's what you need first, a very old craton surrounded by Proterozoic rocks, and then it's there that it's the best environment to look for kimberlites. So what next? Well, still reinvestigating a lot of those ages that were obtained by potassium argon throughout Guyana rock formation. Last week I was on the Cuyuni River on a little dugout to pick up 2 rocks for more dating, and the rest I hope younger generation will do the work. I will be over with that. And we need to do more dating of the mineralization process of various deposits, because there is even younger gold than what we know up to now that I found in one place. So in summary, well, the geological material in Guyana range in age from today, because the rocks still break down from sediments and transported in creeks and rivers, up to 4.2 billion years. As you know, Guyana is always referred as the lost world. There is no evidence for that. It's good for tourists, but at least I could say there was a lost Hadean cross, and we jump in time up by 2 billion years with those results. And if one zircon was found, there is much more to find. So, thank you.
I'm a friend of the Museum of African Heritage in Bel-Air Park.
Yeah.
Can a collage like this that tells us the geological time scale be done for the museum? That people can go in and see this geological time scale?
Well, it was, I could distribute, sometimes I send it free to people, you know, that poster. So what happened was I was supposed to present it 2 years ago, but there were no conference at that time for geology. So I had to delay, but that poster, I made it last year, I updated through the time up to last week, in fact. And but that version, I will give it to anybody who wants it.
Have
And there is also another poster we have that explains the geological process. Was done by the other VSO volunteer that came with me in 2004, Eva Zeliski. So those two could be combined, but those are meant to be given.
At the very beginning, you mentioned freely to schools. Have you done this in schools?
Nope, not yet. No, because this is, I just cooked it last week,
No, but when you began the presentation, you mentioned the phrase freely to schools.
Yeah, but I gave some talks in school already. I went to Queen's College one time, but I did not have that thing yet because at that time the age dating was not done. And in fact, I shall say for a short story, we collected 10 rocks for age dating that was agreed with the Brazilian. And it was supposed to be dated by shrimp in Canada. And suddenly I got contact with the Chinese volunteer who wrote me and asked me to review some papers. I did 2 reviews of papers, and later on his supervisor say, well, if you want, because I asked the price for the analysis, he say, well, to thank you, the analysis will be free. You will just pay for the sample preparation. So we saved like 40,000 US for those analyses. So I got the result in 2013, and last year I brought some rocks in Brazil in my suitcase that broke during the transport. But anyhow, I got it dated, and last week I went to pick up some more rocks, hoping that I could still do more in Brazil with Professor Cordani. But so in the future, if people ask me, and GGMC allow me also, and the new government, how old?
All right.
What was the age of the chemical?
Okay, well, I'll say several, those are sedimentary rocks. Most of them were metamorphosed to high grade. They are granulites, some intruded by charnokites, things like that, but they are all clustered around 1.96, 1.97 billion years. There is a few older crystals, but when I look at them, it's always in the core, and that's mean it's coming from another source, and I believe it's coming from that Adian crust, in fact, and Archean that was just 50 kilometers north of it. So this corresponds to the phase 2 in the Bequests in Suriname. For a long time, people were saying, well, this is probably Archean in age. No, but Zircon said there was a crust nearby that provided the material. In Suriname, they are older, the age is older. But the second phase of metamorphosis and intrusion in Suriname have the same age as the Kanuku. And the Kanuku, there is a granite to be dated, and I'm not sure if it is still true, but it was reflecting the melting of the metasediments. Some are migmatite, but that one was fully melted, and it's 1.96. So that's probably the peak of the metamorphosis and melting. Yep.
So this very old zircon that you found, you're confident that it's not inherited?
Yeah, no, it's inherited. But, you know, you cannot go much more older than that, you know.
Yeah. But so how big do you expect this very old
Well,
coal?
I'm saying it's the extension, I don't know, because I need to collect more rock sample, or somebody else should go. But the minimum extent, I think, is what I showed, the dash pattern. But could be much wider than that. But it doesn't extend in Brazil, because I know they have done a lot of dating work there, and they don't show any in that area age that are older than the volcanic rocks itself, based on uranium lead, but also samarium, neodymium models, age, and all that. On Suriname, I don't know yet, but it's possible it's much bigger, and that need to be investigated, and there they need to do deep geophysics to see the extent of that, because this is what we call a kind of a root, probably underneath those mountains, and it's exactly what they have in South Africa and Canada and Australia. You have those old craton. Well, normally it's just Archean and Proterozoic around it, but here we have even Hadean and surrounded with, and I got Archean age also. So it's pretty good. So we are like second or third, the oldest age on the planet.
There's three other
Yeah,
places that
yeah,
are greater than 4 billion.
Yeah. So we're not even looking for that, and I thought, well, we'll get in trouble because I had some argument with geochronologists about it, because it's done by laser CPMS, and I say, we prefer shrimp, but shrimp will not have reached that core. It's too deep because the shrimp will just go 1 micron depth maximum if they do it if they blast it for a long time. But the zircon, the laser CPMS could go. He went through it, in fact, from the rim to the core to the rim again. So we sit by the signal. And
So what's the age of the rim?
1.98. I got it done on a shrimp in China. I wrote to a Chinese guy. I said, "Can you do it?" And I got it free also, that one. And you could not go inside of it. Yep. Which is the age of the host rock, because I have some zircon that are not zoned, and those ones are the age of the granite itself. Yep.
Thank you.